JWT. JWT. JSON Web Tokens. They're used relatively everywhere. Picture this. You have a website, right? You log into the website and you visit page 1. Page 1 looks fine. Now you want to visit page 2 because why not, right? Why not visit page 2? And you're told to log in again. What's up with that? So you log in again, you visit page 3. Boom, log in again. Do you see how annoying that would be? That is how the internet was before session tokens existed. Now, session tokens, right, is a little different from JWT tokens. JWT tokens provides authorization to the service. Session tokens allow you to retain, a session as long as you're passing this token back and forth. However, the reason why I say this story is because JWT tokens can be used as a session token. In fact, we're going to be using it as part of an authorization header. So technically, by definition, this would be our session token, this JWT token, as we use it when you see it in a demo. Now, that is one use case of why JWT tokens are so useful. It can help provide the authorization and authentication and authenticity. Yeah, all these things. For more context as to why these tokens are valuable, let's take 2 more cases. You log in as a user on an application, right? And you're able to see the request, and the request says role equals user. And you're like, I don't want to be a user, I want to be an admin. So you change role to admin. Do you think that server is going to verify whether you need to have this access or not, or whether you even have access to becoming an admin? Nope. You just became an admin, buddy. Full takeover. So that's why we have tokens like JWT that has a signing request, and there are other tokens out there that have, that can perform this kind of task. And there are non-tokens that can do this stuff. For this video, JWT is a token we're talking about. So the server verifies that sign method, and it'll say you're not an admin, you're just a user. Real quick before I continue. For this video, we're going to assume extreme context. What do I mean by that? Other technologies exist to accomplish things like authorization, to accomplish things like session management, and there might be a lot more technologies out there that might work better than JWT for organizations. For an example, SAML 2.0 uses something called a SAML assertion. That's not necessarily a JWT token, but it works very well for larger organizations, right? For the sake of this video, those don't exist. Just like that. We're not worrying about that. For the simplicity of a JWT token, we're only going to pretend like JWT is the only thing that we're talking about and nothing else. I want to just lay out that groundwork, lay out those boundaries so that we're not, getting confused with other kind of things. But just know that only JWT exists until this video ends. All right, so use case number 2. Let's say I log in as Pap. And no, I don't want to be Pap anymore. I want to be Bob Smith. Well, normally your browser would send a request after you log in and say, hey, my name is Pap. I'm logging as Pap. The server responds with, okay, hey, Pap. But what if I take that response text and I, change some values and I send a message back to the server saying, actually, I'm Bob Smith. I don't want to be Pap anymore. Server is going to just verify me. There's no JWT signing request to tell the server that I actually don't have access to just change my user like that. And guess what? I'm becoming Bob Smith. What's up? I'm Bob. You get the point. Without a JWT token, and if we're not using anything, then the web server doesn't really verify a lot of things. And there's a lot of issues that can come out of that. A lot of those issues happen to be security related. So JWT helps with that security aspect, but it also helps with the aspect of giving information to a user that belongs to the user, right? You don't want to access someone else's social security or password or username if you shouldn't be accessing that information. So JWT tokens are really useful in, as you can probably guess, a plethora of information. All right, so let's actually look at the JWT architecture. Now that we know how a JWT works and what it's used for, at least some of the use cases, then we're going to create our own JWT token. Then we're going to take a look at how our servers respond to some of the misconfigurations. And then we'll just, why not just start throwing out some misconfigurations and start going into what you should do as a security researcher, what you should be thinking of, what questions you might want to ask, and what you should be checking for, especially when you're doing like bug bounty and all these other things. Okay, so this is your JWT structure. Pretty simple. We don't even need to overcomplicate this. We're going to dive in. I'll explain a lot of the concepts, and it should make sense. It's actually very simple. This is a very simple example. It should make sense. And if this doesn't make sense when we create one, it'll definitely make sense after that. Okay, so let's dive right in. The JSON Web Token consists of 3 components. So 3 components make up the JSON Web Token. We have your header. Let me actually use this. So your header is right here, right? That's the first part of your JWT component. Then you have your payload, which will make up the second part of your JWT Web Token. And this is the signature here. It is used to sign the token once you've compiled the header and the payload, and also a secret key, which I haven't talked about that yet, but we'll get to that part. So let's dive into how it's broken down. So really quickly, I haven't added this in, but JWT structure requires that you set a secret key. In this case, we'll assume that we have a secret key that's invisible. We don't see it, but we're going to use it with the signature. All right. When we create a JWT Web Token, we'll get to set our own secret key. So we'll get to see that. All right, let's dive into the values of header, right? We have 2 values, ALG and TYP. Well, let's start with ALG. This is your algorithm, the algorithm that you're going to use to hash the JWT token as part of the signature, the signing mechanism. HF256 hash, it stands for HMAC SHA-256. Nothing complicated. Nothing at all. Then you have your type, right? Type JWT. I think it's always JWT. I don't think I've ever seen a JWT token that had a different type. Don't quote me. Okay, moving on to your payload values, right? Now, I threw a curveball at you. Did you catch it? No? Well, let me give you a hint. Sub. So sub is actually a key. It just ties to user ID. In this case, sub would be the Google user ID equal to this random string of numbers here. That's all. That's the curveball I threw. Let's move on. We have the name, which is Pap. That's me. Pap. You have the role. In this case, I didn't choose role. In this case, I'm choosing whether to say if I'm an admin or not. So in this case, I am going to say that I'm not an admin, right? And you don't want that to be allowed. You don't want to be able to change that, right? You don't want me to change that to true and send it to the web server, and the web server to say, oh, well, I mean, you are an admin. Go ahead and do some admin stuff. That's where the secret key comes in handy, and we'll get to see that later. And then we have your IAT. Don't get it confused. This is just when the token was generated, and that's it. Timestamp for it. That's all there is to it. Lastly, now that you have your header and your payload, you need a signature, which is the last component of the JWT, usually separated by a period. Again, you'll get to see that later. Don't get too hasty. So in this case, our signature is going to be base64. We want to make sure it's URL safe. So base64, URL safe, right? URL safe just means that the web server can understand the request as it comes in. So there are certain things you can do to allow that, like remove spaces, encode certain special characters, like an equal sign, or you can remove the equal sign overall and still allow the signature to work. That's all it means. Now, inside the base64 encryption, we want to hash our JWT web token. So we hash it with HMAC SHA-256. Oh, look at that. It was hashed with the algorithm that we specified. That's how JWT works. Inside that hash, we have our header, which we identified here. This is our entire header. Then we have our payload, which is right here. Here's our payload. Now here's the tricky part. This secret key that we defined, in space, the one that we pulled before we dived into JWT structure that we really didn't pull. This secret key is also going to be the last part of our JWT token when we're creating that signature. Now we hash it, as we say, and then we take that hash and we run it through base 64. And that base 64 becomes our signature. That's a terrible arrow, but you get the point. It becomes our signature. Now, why do we hash it? What's the benefit of that? We'll get to see that later. I'll go through it, but the real benefit is base 64 is an encryption algorithm, meaning it can be decrypted. In fact, base 64 is very easy to decrypt. So it's very versatile. Web servers can read base 64, so it's widely used and really useful. But we don't want our signature to be decryptable. So what we do is we hash it first, and then we encrypt it with base 64. That way, if it's decrypted, the only thing that's revealed is our hash. That's it. Hash is a one-way type of cryptography, meaning it cannot be reversed. So it provides a level of integrity, right? The user can't see what's inside that secret because it can't be reversed. Then there's a sense of confidentiality, right? So you have your secret key that's also hashed. Well, now that secret key is protected as long as the user doesn't have access to your client, which is your browser on your computer. Now, of course, there are other ways to get the secret key, but this is JWT. This isn't, we're not going to dive into those other ways in this video. Okay, now that we know how JWT web token works, let's make our own. All right, let's get into this. We're about to make our own JWT token. No code necessary. We're doing this from scratch. It is beneficial to do this from scratch so that we can understand how JWT tokens work, right? When code is running, you need to know what the steps are that code's doing. So we're doing it from scratch to understand how a JWT token is created at the fundamental level. Sure, you can run code to automatically generate a JWT token, but what happens? What is it that code is doing? What's that library? We need to figure that out. And the more we know, the easier it is to identify things like misconfigurations, other bugs in JWT tokens, which are very common in the signing part of a JWT token. And we'll look at that after. But after we create our JWT token, we're then going to look at how the server verifies that token. And then we're going to dive into some of the configuration errors there. And also, we kind of end off with a little treat for you guys, how we can go about exploiting these misconfigurations and things like bug bounty, penetration tests, red team assessments. I got something for y'all. All right, let's jump right in. So to create a JWT token, it's pretty simple. It's 4 steps. Actually, it's relatively easy steps too. All right, let's dive into step 1. Step 1 is to create the payload. So all we have to do is create a JSON payload. I'm going to be using the command line to do this entire thing. If you're not familiar with the command line, don't worry, I'll try to explain what's happening. If you are familiar with the command line, 2 thumbs up. And good job. Yeah, good job. Give yourself a pat on the back. Okay, let's jump right into the command line here. So the first thing I want to do actually is create our JSON payload. So I'm actually going to open up a text editor, just Vim. Before I do that, I'm actually going to make a directory just called JWT test because I don't want to clutter my operating system. So let's just go inside there. Now I'm going to open up a text editor, Vim. If I can remember my path. Oh, look at that. I remember my password. All right. So what we need to do is create, as we showed in the JSON structured image, we need to create a payload that will take information about the user. And this information is going to be what the server looks at once it verifies that JWT matches, and this is the payload that the server is going to look at, once data is sent over from the client, user's browser to the server, and the server has to verify that data. It ultimately is going to be looking at this payload to know the context about the user, right? What role the user has. What is the user ID? What time was this token generated? Should it be expired? These are the things that we need to include in our payload. I'm going to do a very, very basic example of a payload. So I'm not going to include, every field that should be included in some of these payloads, but you get the picture. All right. So for starters, we use JSON. When we actually do the encryption, we will have this all one line, but for the sake of doing this initial step, we're going to separate the lines here and just make it easy to read the JSON. So for the first payload, let's say we want user ID. Let's start there. So user ID and then JSON format. We keep our JSON format, and I'm going to enter 1. User ID equals 1, right? So now we need another payload, another key value pair. So let's say we do role as another one, right? Role will be, this time I will be a user, because we'll assume that there's a user role. You know what? Let's make this more interesting. We'll say our role is dev, right? We want to be devs here. Let's go into, let's say expiry maybe. Yeah, expiry. And we're going to, oh man. Now, I don't know Unix time. I'm going to enter random numbers. We'll pretend like this is Unix time for right now, right? I don't know. Let's say we start with 7. I think it starts with 7 right now. So that's expiring. All right. And then we need our IAD, right? When the token was generated, because that's going to be what we use to determine whether the token's expired or not. So it's expired at this time. And because it was issued at, I don't know, let's say we got to get the first few numbers pretty close to the expiry, just so that we're, we're not leaving this token on forever. All right, there we go. So now we have IAD. Now let's add one more thing to our token. We can add name. I almost forgot about that. Now, theoretically, for just for making things cleaner, name should have been under user ID, but we're rebels. We don't care. All right, so the name will be Pap. We'll have Pap. Now we have our JWT payload right here. Now, like I said, this is all going to be one line and converted into base64 later, but let's save what we have. Okay, since, I'm a dunce over here, I never actually named the file. I just went into the text editor of Vim, but I never named it, so we're going to name that right now. We're going to call this JWT payload.json. All right, and now we should be able to exit. All right, so now we have our JWT payload, and we can check. We have it right here. So now we have our payload saved. We can move on to step 2. Okay, so now we need to make our signing key, and also we need to start talking about what algorithms that we're going to use for this JWT token. There's a few algorithms out there, and we're going to select one of them. First, we need to create our secret key, right? That secret key that was floating in space before. It's actually very easy. You can do it with OpenSSL from the command line, and this key is going to be base64 encoded, and we're actually not going to set a hard coded key. We're not going to, password 1, 2, 3. We're not going to do all that. We're going to make the key random, and we're just going to use a random base64 encoded key. So it's actually relatively easy. If you have the OpenSSL tool, you can just type in OpenSSL in your browser, and we want to do a random. So we just type rand, right? And we want that random key to be encoded with base64. So base64, and we want the bit size of this to be 64 bits. So run that, and we have our key. Now, the interesting thing about this key is it is not reversible. Right? base64 is an encryption algorithm, so by default it should be reversible. But when we try to reverse this one, let's just pop that into an echo, and then we will pipe that to base64d, and we get this random jargon. That's a good thing. You don't want it to be reversible. You want it to be random, because this secret key needs to not be discovered, because then an attacker can just take the plain text, encode it with base64, and boom, they can access whatever it is that this JWT allows to access utilizing this JWT token. Now, there are ways around that, to prevent replay attacks and things like that for JWT tokens, but we'll get into that later. For now, we have our key. And actually, what we're going to do is take this key and we're going to save it into a file. So I'm going to echo this key, paste. All right. Oops. And I want to pop that there. Let's go to the end of the file, and we're going to output this to a file called secret key, secretkey.txt. Boom. So now we have our payload and we have our secret key. There's only one more thing we need to make. That's the header. So let's make our header. And the header is where we actually start defining the algorithms that we want to use and the type. We know what the type's going to be, but we don't really know the algorithm we're going to use yet. So let's figure this out. So I'm going to go back into the text editor Vim. This time I'm actually going to name the file beforehand. I'm not going to wait till the end. So we'll name this JWT headers .json because JSON format. So let's open that up, and we are going to we're going to start with the JSON squiggly brackets, and we need to start with our type, right? That's the type of token that we're making. It's always JWT because we're making JWT, self-explanatory, unless you want to confuse a lot of people and start naming things differently, but we don't do that here. Now we need to define our algorithm. Now, just like in the example, when we use HMAC and SHA-256, I want to use that same algorithm just because we use it in the example. And it would make sense to use it, to be consistent. All right, let's jump into this. So we're going to do HS, so HMAC and SHA. And we want to specify the key size, or the bit size, in this case, 256. All right, that looks good. Looks like our header is good. No errors here. So at least it doesn't look like there are any errors. We'll figure that out later. All right, so now we have three components, as we mentioned, of the JWT web token. We have our JWT header, we have our JWT payload, and we have our secret key. Now we can move on to the fourth step. And the fourth step is to create that signature. As we saw, creating the signature is pretty much just utilizing the HMAC SHA hash on the header, the payload, and the secret key. And then we're taking that hash and we're running it through base64 encoding, and we're making it URL safe. In this case, we're not going to go the whole route of making it URL safe. That's something the server client does. We don't really need to do that. But we are going to base64 the hashing algorithm so that we can see how it works and we can see the end result of the JWT token. Okay, so for that, we need to do quite a big command. So bear with me. I'll explain what I'm doing, and then we'll go from there. So first, what we need to do is remove the spaces in our data, right? So I'm going to go back into the JWT payload, and what we'll do is just make this one line. Oops. Boom. Like that. And this is because Linux doesn't really like the spaces here. Same thing with JWT. Doesn't really like spaces, so we're making that all one line. Looks good. Now we're ready to make that JWT. Now we need to do the same thing for our JWT header. So Vim JWT headers. Looking good. Boom. 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 Now we have our header and our payload ready to use. Okay, now that we have the JWT payload as one line, no spaces, and a JWT header, one line, no spaces, now we can go ahead and base64 both of them, and we're going to append that to a file. And then from that, we need to append the signature at the very end. So as part of the signature, this has to be done. This is all part of the JWT process. So I would say step 4.2, if that could be considered a step, would be to base64 the JWT payload first, and then we'll do the header. So what we'll do is we'll just we can concatenate. So we'll just print the contents of JWT payload, but when we print it, we're going to base64 encode it. And so that's what we're doing here. Very basic command. So this is our base64 encoded payload. So this will actually have to go to a file. So what we'll do is, actually what we'll do is we're going to rerun this command, but this time I'm going to append it to a file. So let's do signature. We'll do this. We'll just say JWT token, JWT token dot txt. Okay, I'm gonna cat JWT token. Oops. There, we have our payload. All right, so the structure of a JWT, as I mentioned in the web token, is header, payload, signature. So we need the header to be in before the payload, and we need the signature to be after the payload. So what we're going to do now is base64 encode the header. So let's do cat JWT dot headers, and then we're going to base64 encode that one. And here we go. Now we have the header. One thing that I'm going to note is we're going to actually remove the equal sign. So it is very common for servers to just remove these double equal signs here in the base64 in order to process the JWT token a lot better. So we're going to remove these two equal signs and pretend like our server doesn't care about these and automatically dropped it. So what we're going to do this time is add that to the JWT token.txt file. But what I'm going to do is actually open up the file and then add it that way instead of appending to it, because I want it to be in the beginning before the payload. I don't want it to be at the end here. So I'm going to add a few spaces here because Vim likes to mess with me sometimes. And it looks like we just copied just the equal sign. So I'm going to get out of that, and then I'm going to go back and copy this. There we go. And JWT is usually separated by a dot. So now we have our header, dot payload, and at the end we need to add dot signature. All right, so let's close out of that file. So we have two components for our JWT token. Now we just need to grab that last component. So in order to get the last component, what we need to do is actually take our token, so the header and the payload, and then we need to run it through the hashing algorithm that we did in the architectural diagram that I showed, which is HMAC and SHA-256. Once we hash that payload and header combination mixed with the secret key, of course. So we hash a header, payload, secret key. Once we hash that, then we run that through base64, and that gives us our signing signature. And with the signature, we can then append that to the end of the JWT token, and we have our full JWT token. So a lot said there. Let's go through it. It's a lot easier when you see it. So the first thing I need to do is, well, we need to actually, JWT token. So we basically just need to take this and we need to run this through what we're going to do. So we could have concatenated the file, but I'm gonna just copy and echo just to make it a lot easier. So we need to print out the content of our header and payload while they're base64 encoded. Whoops. There we go. Base64 encoded header and payload separated by the dot there. Now what we need to do is we're going to hash our secret key with HMAC and SHA. And then we're going to use OpenSSL to convert the entire thing to base64. So let's do it this way. We're going to OpenSSL and we'll say digest, and then we'll use SHA-256 for hashing, and then we'll combine that with HMAC, and then we'll use our secret key, which I failed to get. So we're gonna jump into another session here just to pull our secret key, because of course I didn't remember it. So let's cat the secret key. Let's grab this. Boom. Copy. Let's go back to our first shell. All right, so secret key goes in here. Boom. And boom. Secret key. All right, so now what we want to do is also, while we're hashing it, we want to convert to binary as well. So, and then what we want to do is take that and run that through base64. So what we're doing for this is we're taking our header, our payload, and then what we're doing is we're running that through SHA-256 and HMAC, and we're using this secret key to sign the hash as we're doing it. Then we take the entire output, and also, the binary conversion here. Then we take the entire output and we run that through base64, and that should be the full JWT token. Looks like I had a typo here where instead of using digest, I use DST, but that should be digest for the hashing algorithm. All right, so it's SHA digest and HMAC digest. So I think it's DG ST for digest. Now let's run that. And there we go. I'm going to clear the screen and run that again just to make it a lot more clean for you guys. But here we go. We have our signature right here. So we can take this. Remember, we don't include the equal sign. Right. Now we can go into our JWT token. And let's put period here. And let's append the signing key. Now, here. And we can, let's clear the screen, and we'll do cat JWT token. And we have our entire JWT token. We have our header here, we have our payload, and we have our signature. Look at that. So how do we verify and make sure that this is actually a JWT token? Well, we could do it a very easy way. There's a website called JWT.io that we can use to verify that this is actually a valid JWT token. In fact, let's do that. Let's do that. I'm going to open a window, and let's drag it down here so you can see it. Let's make that a little smaller. All right, now let's type in JWT.io, and what we're going to do is take our JWT token here, copy that. And we're going to paste it here. And we can verify some of the things, right? We set the JWT token, so we know the contents of that token. Header, yep, header looks good. We did set it to JWT, of course. Hashing algorithm, we set to HS256. And then we have the payload, right? We set the user ID to 1, the role to dev, the expiry, IAT, issued at or created time. And then we set the name to PAP. So we know our JWT token is a valid token because it's giving us this information. Now, if you notice here, it says invalid signature. This is because the signature cannot be verified because we have not entered a secret key for this JWT token. So this is what actually prevents users from just altering a JWT token and resending that request, right? So if I change this role to admin, right? Sure, it says signature verified, but if I sent this to the server, it will not be verified because the signature is not included or is not valid. I don't have the secret that is used to rehash, the header, the payload, and the secret, and then convert that to base64. So right now, you can pretty much see what's happening, right? It's hashing the base64 header and the base64 payload, but I don't have the secret. So if this went back to the server, I'd be missing the secret and the server wouldn't be able to verify. So in order to make this a valid JWT token that the server remembers, we would need to know the secret key. And this is what makes JWT powerful, because from a hacking perspective, if we don't know the secret key, then we're not getting in, right? Now we can sit here and try to brute force a secret key. Sure. Let me know how that goes. In some cases, yes, it would be possible to brute force a secret key, but it's going to take a while. So we will need that secret key in order to actually change some of these values, rehash it, and push it back to a base64 so that the server can verify. Now there are pros and cons to JWT. We'll get into that a little bit later, but this is a JWT token as a whole. All right, we know how to create a token. Let's look at how a server verifies this token. We're going to take a look at a very basic API. We'll request a token, we'll see the server issue our token, and then we'll see how it works when we use a token, and what happens if we're not using the correct token in a signing request, or in a request that is signed with the incorrect signature. Then we're going to get into some of the common misconfigurations and take a look at some of those configurations. And lastly, we're going to talk about some of the things that we can do from a cyber perspective to secure JWT tokens, and also from a cyber offensive perspective when we're testing these applications, what to look for in JWT tokens, now that we know how it works. All right, so we just learned how to make a JWT token, and we just learned how to sign it with a secret key and grab our token. Now we're going to figure out how the server uses that token in order to provide authentication or authorization in this means. Now, like I said, there are other ways you can use a JWT token. You can even use it for single sign-on and other things like that. For this use case, we're literally just doing authentication, right? And authorization, actually, in this case. So let's show how it works. I'll talk through some of the things, and it should be really easy to understand given the context of what we just did. Okay, so what I have here is a very basic post request. So I'm simulating a web browser. That's it. That's all it's doing. Simulating a web browser. In this case, we're simulating a login. So when you go to type in your username and your password, and we'll just assume that it's also asking for your email. We don't have to set it like that, but we'll assume that. You type in your username, your password, your email, and then we'll say that you entered, you click the submit key. What does the server do with your client, with your browser? They have to communicate. So let's figure that out. So what we're going to do is I'm going to log in. Let's send that request. Of course, this is not working. I didn't turn on. I'm such an idiot. I didn't start the code. Give me 1 second. All right, we are back. So I started the API. We're good. I also noticed that the web address that we're using was also, I was working on something else. It wasn't set right. I changed that. We're good to go. All right. So now let's pretend like we're logging into our application. And I'm going to run this and simulate a browser login and see how the server responds. Send request. And we see here. So the server responds with status 200, which is usually used for OK. If someone uses that for something else, then there's something wrong, something going on there. But it's usually used for OK. And then we have our message, which is telling me that I successfully logged in. So I'm in. Now, here's the communication path, right? Token. It sends a token back to my web browser. In this case, we're not actually using a web browser, so I'm going to have to manually copy this token. But this is our JWT token. It contains information about who I am as a user. Right. In this case, if I'm an admin, well, in this case, I am an admin in this JWT token. So it should tell me that I'm an admin, or if I'm a user, it should tell me I'm a user. That this is our JWT token. It gives the server the context of who we are when we're making our requests and sending data back and forth between the client and the server. So let's go to try to do something that only admins can do. Right. Let's go to get all users. I'm going to close this response here so we can see a new response. Let's send this request. And it's giving me authentication failed because the API, right, is trying to verify if you have permission to do this action. And it's saying, hey, we don't have any kind of authorization token, right? We can't verify that. Now, what I'm going to do is add a header, authorization, and I don't know. We'll say authorizations, you go to test, or we'll say test D there. Doesn't matter what authorization is. Let's send that. We still get authentication fails because we're not using a valid authorization token. Now let's paste our JWT token and let's delete one character from the signing, from the signature there. So now that one character, we delete from the signature, send that request, nothing. Still get authorization failed. So as you can see, you need to have the complete signature, right? Along with the JWT header and the JWT payload. So payload here, header before that, signature after that. And that's the full JWT structure as we already went through. So let's run this. Boom. Now that we ran this, we get to see our users. Well, we get to see more than just us as a user, but we get to see every user. So theoretically, yes, if an attacker were to grab a JWT token that belonged to an admin, that's bad news. That's bad news, right? They can see all the users. Now, passwords are empty, but you know, I've seen some cases where passwords are just displayed hashed. I don't recommend that at all, but it happens. Now, if you do like a DB dump, yeah, sure, you'll see hashed passwords, but in this case, they have usernames, they have emails, they have user IDs. And in the world of bug bounty, this will be treated as probably a low to medium. It depends on the company. It really does depend on the company, but this could be information disclosure. And when I say it depends on the company, collectively, right? Information about a user collectively can be considered PII, personable identifying information. Said that way wrong. PII, personal identifying information. That's PII. And that's usually private data about a person, which if you have a username, if you have an email, if you have the person's name, first and last name, if you have their, let's say, date of birth, for example, collectively, all that information can be considered PII. But individually, they're just public information about a person, at least in the US. So depends on the context, depends on the company for if that's going to be some kind of information disclosure there. But we see that our server verifies the JWT token and gives us back what we need based on the signature that we signed. Now, what happens if the server did not verify the signing signature? Let me make some changes and let me come right back here to show you what happens if there's no checking for the actual JWT signature. Okay, I made some changes. So let's test it out. So now we can send the request with our JWT token as we see, and everything returns. So let's pretend that our JWT token was not validly checked, meaning the signature here was not checked to verify that it was a valid JWT token that was issued by the server, right? So I'm going to delete this signature, right? And we're going to send this request as it is here. And let's close the response and let it so you can see any changes and none. Without a signature, it actually still lets us view all users as an admin. Now, in this particular case, we assume that my role was an admin, although I did not set the role in the users table here. But where this can be really dangerous, right? If a user had the user role, well, you can, this is a base64 encoder, encoded string, right? So you can actually, let's open up, MobX term again, and let's take a look at what we can do. So we could echo this one just to print the contents on the command line, and then we can base64 decode it. Now we want to add the equal sign again just for the base64 sake. And let's decode it. So we have the contents of our token, right? And let's say this was a role here. We're just going to make up a scenario here. We can echo and we'll paste the contents. All right. And let's say we had another field called role, right? Let's say that role was set to user. Well, we can make that to admin. And then we can, what I want to do is single quotes here because the double quotes is going to confuse our shell. We don't want that. And then we're going to base64 encode this. So base64, boom. So now we have a new JWT token, right? And if we went back to our payload, or sorry, we have a new JWT payload, not token. If we go back to our payload, this payload now includes a role admin. And if it was not verifying the signature, well, we just became an admin and we just, got to see everyone. So this is why it's important to verify that signature with the secret key that's set, and why it is harder to forge that signature without having that secret key. And it's also good to set a secret key that is not easily to brute force. So a lot of things to be done in order to make sure that a JWT token is correctly configured. Now you can verify this part of the JWT token, the header and the payload. Great, you should be verifying these things. However, If you don't have the signature, it does not matter if you verify these two here, because once something is changed, the server is going to accept whatever it is that was changed, because there is no signing mechanism that says this is authentic or not. Right. So that's how the JWT interacts with the server, and that's one of the misconfigurations that happens with the JWT. Now let's look at some common misconfigurations, not demo, just a list of common misconfigurations, and then we're going to talk about, okay, well, if I was a hacker, what could I do with that misconfiguration? All right, let's talk about some common JWT misconfigurations out there. Now, developers, we ain't bashing you. Developing is a hard thing to do. Sometimes there's going to be some misconfigurations, and we need to go through this because as security engineers, security analysts, security researchers, security enthusiasts, all the above, these are some things we got to look into. So one of the first common misconfigurations, and this is not just stuff that I've seen, but stuff that are out there. There are a lot more than this. I do want to say this list is not exhaustive. It is very limited. There's a lot more JWT misconfigurations. For the sake of this video, it is a beginner level video, and I'm not about to go through hundreds of different misconfigurations if they exist. So we're only going to go through about 6 or 7 of them. All right, so one of the first common misconfigurations are failure to add an expiration time in your payload. So that JWT payload where we created when we defined the expiration time, what happens if we remove that expiration? But I think it's self-explanatory, right? The JWT token will not expire, meaning that the server will continuously accept that JWT token forever. We're not ever losing that token. Now, let's put that in perspective, right? There are 2 attack vectors that I can think of without having to do any kind of critical thinking, any thought, or having to ask any questions. 1, if I have the same JWT token for the rest of my life, maybe I can then start to try to figure out the signature, brute force, whatever means necessary. And if I figure out the signature or that secret key that we used, if I figure that secret key out, well, now I can go and change the payload and, assume whoever I want to assume. 2, if that JWT token exists forever and it is assigned to your user account, all it takes is for one person to get access to that JWT token, and they can be you forever. So, expiration, set those. You want to set those expiration times. Okay, another common misconfiguration, weak secrets. In the demo that I use, we actually used a secret. It was randomly generated, but it was pretty much just a secret. An example of a weak secret is literally taking something like password 1 and running that through base 64. Bad example, I know, because you can just decrypt it back to password 1. Let's say we ran SHA, HMAC SHA 256 against it, then put it through base 64. You can't reverse it. You can reverse it back to the SHA hash, but you can't actually reverse that hash back to password 1. But you don't need to. Someone can guess. That's easy to brute force. Slap on rocku.txt, run that through some kind of brute forcing tool, done. Easy. So weak secrets, no go. Don't do that. In fact, it is actually more common for JWT tokens to use a PKI system for that secret. A PKI system has to do with a public and private key pair. I won't go into too many details in this video, but I will make a video about PKI, how it works, public-private key pair, and then we get to, that'll be a fun video because then we'll get to open up, some of these public key algorithms like Diffie-Hellman, RSA. We'll get to open it up and we'll get to see how the math works behind it, and we'll even, scratch our own mathematical equation that will encrypt something with RSA and Diffie-Hellman. Sounds like that'll be fun. Okay, let's move on. Another common JWT misconfiguration is failure to verify signatures and weak cryptographic algorithms for signing. So failure to verify signatures, self-explanatory. In the demo I showed, we showed what happens if you do not verify a signature. That means anyone can do anything in any context without having the server verify that the JWT token is a valid token, at least for the session duration and at the time of generation that server had generated, and for the duration of the session that that server had generated it for. All that to say, servers need to verify the signature of these JWT tokens. We do not want JWT tokens to just come out of Wonderland, making changes and sending data that we don't want it to be, we don't want to be sent or changes to be made. And we don't want the server to just start accepting those things. In line with the failure to verify signatures, weak cryptographic algorithms for signing, we don't want. So in our example, we used HMAC and SHA-256 to hash the header, the payload, and that secret key. And then we took the hash of all three of those components, and we ran that through base64 encryptor to create our base64 encrypted JWT token. Now, what if we didn't hash the token and we just took the plain text JSON, right? The header and the payload that we had that was in JSON. What if we just took that and we ran it through base64 and then created our JWT token like that? Well, that technically is an example of a weak cryptographic algorithm because it can be easily reversed back into the JSON file. So we could reverse that base64 encoded string back into a full JWT plain text. So we have the header, the payload, and the secret key. And then we can change the header, we can change the payload, and then we have the secret key already. We can just reuse it. And a server should accept it as long as that signing mechanism is valid and is not expired. Big issue there. Okay, another common JWT misconfiguration is token leakage in the web app. So what do I mean by that? We know that the flow of traffic, right, when we're sending a JWT token from the server to the client, there needs to be some kind of request first. So we know what happens is the client, the browser, sends a request. In our example, it was a login request, right? The server responded to that login request with the success message and then the JWT token. And then our client, the browser, right, can now perform functions on behalf of us. So it's us, we are our browser, right? One and the same here. So as we perform functions, we would send an authorization header, which contains that JWT token, to the server. And the server will then verify that JWT signing part, the last part of the JWT token. If it is valid, the server will allow us or disallow us, depending on the role that we have, to perform these tasks. Or it might come back and say, access denied or something like that. So that's the flow of JWT tokens. We know that. Now, what happens if the server accidentally leaks our JWT token to someone else? Account takeover. No brainer. If I go and log into a website, example.com, and example.com gives me the JWT token of Bob Smith. Well, I'm Bob Smith now. I'm him. So no, we do not want any kind of token leakage in the web app. In fact, that is a serious vulnerability if it ever does happen, and it should be addressed if you're dealing with customers and users, and you're storing their information in a database and your or a data store, or storing their information anywhere, and you're using a JWT in order to authenticate these users. You don't want to leak JWTs into web apps. It's not something you want to do. Okay, another common JWT misconfiguration is failure to validate the JWT token. Now that kind of goes with the weak secrets and failure to verify signatures. If you don't validate the JWT token, which this expands beyond just a signature, for example, validating the signature is just validating that the token is valid. For one, the request is valid when you send a token, and it allows the server to then allow you to access resources or send data in the context of what the payload was in that JWT if the signature matches, right? Now, failure to validate the token at all, it basically means I can just remove the authorization header, still access a resource that I should not be able to access. That's a problem. So that's something that should be checked, especially if you're doing some kind of security research, bug bounty. Remove that auth header, remove that JWT token, and see if you can access it. If you can, well, you just have failed JWT validation, which is a misconfiguration. And then you have vulnerabilities in the cryptography used, right? So we use HMAC and SHA-256. If there were ever a way to we don't reverse hashes, right? But we can try to match a hash, or we call that like a birthday attack, or something like that, where we can generate a string that has the same hash that as another set of strings. So if A hash is equal to 1 and B hash is equal to 1, we call that a birthday attack, because when we verify the signing of a JWT token, the server is actually verifying the hash of that signing part of the token. It's not verifying the actual secret. So if the hashes are the same, it will allow you to proceed regardless. So that's how it works. But we do not want to use cryptography that has vulnerabilities such as that in it. And we want to make sure that we're keeping up to date with vulnerabilities that are introduced in current cryptography, or cryptographic algorithms. But this is also another, it's not a misconfiguration, so I guess it doesn't belong here. But it is a word for a concern. It is a worry that, as cybersecurity progresses, as technology in general progresses, that there are going to be new vulnerabilities that come out. And if we're, as researchers, are on top of these vulnerabilities, we might be able to identify vulnerabilities that affect cryptography. If that's the case, look at those JWT tokens along with the other places that use cryptography that you should look at. Okay, so summarize, right? You're doing a pen test, you're doing a red team assessment, you're doing bug bounty. You see a JWT token. What do you do? What do you think, right? How do you approach that situation? Few things, right? You need to check and see if the token expires. One, if the token doesn't expire, you might be able to do something with that, right? You try to use JWT.io and see if you can just guess a signature. Brute force, however you want to guess it, right? It could be PKI, I don't know. See if you can guess it. Try to remove the signature and see if the server still accepts the request. If it does, you got another bug there. Try to remove the token overall and see if the server accepts the request. If it does, you got a bug. Try to check other places of the web app, different paths, different subdomains. Look into JavaScript. Some of the JavaScript, sometimes you see keys that are hard coded, and see if there's any reference to what that secret might be for JWT token. If you find that, you probably know what you got. Yup, a bug. In this case, it would be information disclosure, but it's still a bug. And one last thing I would say, put the JWT token into JWT.io. Look at the payload and see if you can change some values and resend that request with the changed values. Because even if the signature is being validated but not being validated correctly, you might be able to become admin, or you might be able to become Bob Smith. There are a lot of other questions you can ask when it comes to JWT tokens. How is it, in the context of what we're talking about, we've asked basic questions like, is the JWT token being validated? Is the JWT token using a weak password? Is the JWT token expiring? We ask those basic questions, right? There are a lot of other questions you can ask about a JWT token, but at the very least, simple terms, ask these questions every time you're doing a security assessment or doing some kind of research, and then build off of these things here, right? This video is not to just limit your knowledge to these common JWT misconfigurations and how JWT works, but it's to give you a starting point, right? It's up to you to use Feynman's technique, as mentioned in the first video, to expand your knowledge on JWT and use it to find new vulnerabilities, identify other misconfigurations that weren't identified, implement more best practices that you might find, or help others. That's up to you. You're still here. It's been about an hour, and you're still here. You made it to the outro. Congratulations. Hope you liked the video. If you did, you know what to do. Hit the subscribe button, like, comment, hit that notification bell for more videos that come out. And I hope that when you end this video today, hopefully you end this video today, that you have a better understanding of JWT tokens and you're able to recognize them when they show up. But also during your bug hunting, you're able to ask the right questions, figure out what JWT token misconfigurations might be available, and go get that bug or do that red team test or penetration. Just, I don't know, man. Do what you want with this information. All right. Pap out.